All right. Hello, everybody. Welcome to my presentation, JavaScript powered smart home with almost no code. So, so today I'm going to talk a little bit about a lot of different things. Actually, I'm going to talk about JavaScript first and foremost. JavaScript is by far my favorite language, so I always like to talk about it. I'm going to talk about smart home devices, IoT devices, and how they fit with JavaScript, and we're going to talk about so. Uh, I'm not sure how many attendees we'll have. This is a developer conference, but I'm gonna talk about why you should not write in code. So that should be a fun one. So hi, my name is Joel. I'll be here today. I'll be your speaker for this session. The session should go around for 35 minutes, and I'll be taking questions at the end. So feel free to ask the questions in the chat if you have any. I'll be monitoring the chat. If I see something, I might stop. Or just feel free to say hi. Just say hi. Tell me where you're from, and what you're hoping to get out of this session. So I'll jump right into my session, and welcome to JavaScript powered smart home with almost no code. So I'm going to talk a little bit about IoT devices, and here's the thing. You might wonder, why should you care about IoT devices? Well, I mean, it's kind of getting more and more obvious, but there's a lot of IoT devices out there. It is actually expected that by 2025 there should be about 75 billion devices connected on the internet or on the planet. And I was actually trying to map this curve to something. I was trying to figure out, like, is it the world population that is increasing? Definitely not at that rate, for sure. And that led me to some interesting questioning. I was wondering, well, based on the projections of the world population and the number of projected devices, that means that there should be an average of 6 connected devices per person. I was like, there's no way. There's no way I actually have 6 connected devices per person in my household, or there's 2 of us. So I started thinking, what do I have that is actually connected to the internet? So of course I've got 4 laptops. I've got 2 of my own. And my wife also has one. And we have one for the family. So that's 4 connected devices. We each have a cell phone as well. So that's right there. You've got 6 connected devices. Now, some people might argue that those cell phones and tablets and so on are not like IoT devices. So I started, okay, let's see if I actually have some connected devices, like IoT, classic IoT devices. Well, I've got my thermostat. My thermostat is one for sure, so it is connected, so I can actually change the temperature of my home when I'm not there, which is kind of convenient. All my smoke detectors, they're also connected, so I know if there's a fire and I'm not at home. It's also easier. I can just take it off when it starts beeping if I burn something when I'm cooking, and I don't have to go and try to vent in front of it. My TV is also connected, so I can actually watch Netflix directly on my TV. I've got some smart bulbs. I've got a few bulbs that are connected, so I can turn them on or off using my voice. I've got some plugs that are connected. I use those for my Christmas lights outside. So I've got a few of them. My speakers. I've got a bunch of connected speakers, which are actually connected to streaming platforms, so I can actually listen to music. I've got home assistants, those little devices, which I'm not going to name because they're actually going to answer to me. Uh, but those little devices, they can be useful. Oh, my door locks are actually connected to the internet. Not sure if that's a very smart decision or not. And I've got a vacuum because you always want to be able to access your vacuum while you're not at home. So it turns out that, well, that's like 18 IoT devices for the 2 of us, so 9 each. So yeah, it definitely makes sense that we're talking about IoT devices, because there are more and more out there. And when you start thinking about it, there's a lot of connected things that we have around our houses. So before I just jump into my topic, let me introduce myself. So hi, my name is Joel. I am based in Ottawa, Canada, where it's so absolutely lovely today. We've got a nice sunny day again coming up. It is currently 7:30 in the morning. So I just finished my first coffee. I think I should be good, but I might have my morning voice a little bit still. So I work as a developer advocate for MongoDB. You might have heard of that. That's a document database. And if you ever want to get in touch with me, I love Twitter. That's always the best way to reach me. So my Twitter handle is Joel__Lord, and you can always reach me out there. All right, so before we jump into the topic, let me just give you this little warning. I'm just a hacker. I love playing with technology. I love technology. I love tinkering around. If you're looking at information to build like real IoT devices that will go out there in the wild, well, there might be better sessions. Uh, but if you're looking at getting into it and exploring different technologies, I think this will be a great session for you. So JavaScript, IoT, and low-code interfaces, this is what we're going to talk about today, as I've already mentioned. So I'm going to talk a little bit about IoT and JavaScript, and talk about low-code interfaces, and I'm going to talk a little bit about some of the problems that I have with my IoT devices and how I fixed some of that with using low-code interfaces. You're going to see that's actually some pretty cool stuff right there. As I mentioned, feel free to ask any questions in the chat. I'll be monitoring the chat. I am actually monitoring at the moment. Seems very quiet, so that's all good. But if you have any questions, just feel free to ask away, or just say hi. Okay, so why don't we jump into our first topic at hand, because we've got a lot of content to cover today. IoT and JavaScript. They actually work really well together, like peanut butter and jelly. So this is actually a presentation that I did just a few years ago. And let me just, can I get out of the way? No, I think I'll need to stay there. But what you see here on the screen in the back, let me actually get out of the way. There it is. Okay. So what you see here in the screen on the back, you'll see kind of a skeleton. That is actually a connect from my Xbox that I've connected using some JavaScript. And from there, I was able to get some data on the skeleton of a person. And I built a library that detected gestures. So I've used those gestures, and I've connected this tiny little robot that you see at the bottom right of your screen, which had wheels, and it would react based on the gestures that I would do. So essentially, what I do here is that I swipe, and the robot just flies off the table. It actually goes a little bit faster than I originally planned, so I kind of broke it at that conference. Um, but you can kind of see all the different kind of things that you can do with IoT, and or with JavaScript, I mean, and connected different devices, connecting stuff like a Connect sensor, connecting a little robot, and so on. So let's just see it again, fly off the table. There it goes. Okay, so getting started with IoT and JavaScript, there's a lot of different ways. A few years ago, I'm going to cover two of them. I'm going to talk about the Espruino more specifically, or the Arduino hardware platform, and a little bit about the Raspberry Pi. So a few years ago, we were talking a lot about the Arduino. Arduino is a tiny programmable microcontroller that you can use. It's all open source. The hardware is open. The code is open. Everything is open. A great little platform, but it had to be programmed in C. So a few years later, and it was somewhat limited. It's a great little microcontroller. It's a great fun platform to use. But the one that I've really enjoyed recently is the Espruino, which is kind of a more modern version. It's inspired by the Arduino. And it has a Wi-Fi connection, or a Wi-Fi chip directly on it. So it is based off the ESP8266, if I can recall correctly, and it's just a Wi-Fi chip. So out of the box, you can actually use that and connect to the Wi-Fi. Another nice thing about it is that you can actually program it using some JavaScript, or a language very similar to JavaScript. So Espruino Wi-Fi is a tiny USB and Wi-Fi enabled microcontroller that can be programmed in JavaScript. Just plug it into your computer and get started in seconds with the web IDE. No software installation needed. So you can take a look at the website right here. This is actually the definition from their website. So this is the IDE. Actually, this is what it looks like. So you can actually go to espruino.com/IDE, and right from there, you can actually program and start programming your Espruino. So as a matter of fact, I actually have one right here. If I can actually dig it out of my pile of cables here. Come on, focus. All right. So believe me, there's an Espruino right there. Um, and unfortunately, I can't use this interface because it's actually connected on in an iframe, but I do have the IDE loaded right here. So this is the actual IDE, and let's connect to the device. So I can now connect to my Espruino board, and it seems like it's actually doing something. Oops, it seems like the cats jumped on my keyboard last night. So there's a bunch of stuff right there. Let's just remove all of that. It's actually already running, but you can see this is the code that I wrote. I can actually just add my semicolon here. This is just a blink. I'm going to show you the code in just a second, so don't worry if it's tiny and you can't really see it. I can flash this code to my board, and you should see a LED blinking in just a few seconds. So if we want to make that a little bit slower, let's just change the interval here, flash this board again, and you should see it now. It's a little bit slower. There you go. All right, so this is kind of how it works. So there's a built-in LED that you can use. You can console log so you can see what's going on and so on. So relatively easy to use, relatively easy to program. Basically, just plug it in, use the web IDE, and you can actually write some code. As I mentioned, the code is pretty much JavaScript. So in this case, I'm setting a status to false. Use a set interval, so that will, every 500 milliseconds, it will trigger this callback. I just change the status, so from false to true or to true to false, and just toggle it. I do a console log, so that's what we were seeing on the left side. And I just write to the LED the status, so either true or false, which will turn on or off the LED that is on the board. And that's it. So you've wrote your first IoT device. That's it. The blink example is always the hello world of IoT devices. So this is kind of what it looks like using an Espruino. The other device that you can use, which is actually very interesting. This is the Raspberry Pi, so Raspberry Pi 4, which was recently released. It's actually a tiny computer. I've got one right here. Let me just try to pull it. But this one is a little bit more tricky because it's got a bunch of cables wider to it. Come on, there it is. So it's just a tiny computer. It's about maybe like a large credit card size computer. Um, and it has everything. It's actually a computer with I think it has something around, like, you can get one with 4 or 8 gigabytes of RAM for about $50 US. They're actually at a decent price range, and it's an actual computer. So you can see here that it has USB connectors, it has an Ethernet, it actually has Wi-Fi on board, and it has 2 HDMI outs, so you can connect dual monitors, you can connect a keyboard and a mouse, and there you go. You've got a fully working computer. This can actually be very useful for different reasons. You can use it as an IoT devices as well, because it has all of those little pins that you can see at the end right here that you can use to interact with different connected sensors or LEDs or whatever you want to connect there. So Raspberry Pi is your tiny dual display desktop computer and robot brain, smart home hub, media center, network, AI, core, factory, controller, and much more. So once again, that's the definition from the website. But what does it do really is that it's a tiny computer. And in there, you can actually, it comes out of the box with JavaScript or Node.js installed. So you can just use the library called Johnny5, run npm install. You can install this library, you can write some code, and you actually have access to those little pins, and you can control things like a LED that would be connected to one of those pins. Right here, this is actually connected to my Raspberry Pi. So as you can see, it has a full UI. It's a Linux distribution made specifically for the Raspberry Pi, based on Debian, which is called Raspbian. And in here, I'll just need to use this other keyboard right here. But you can see that just before the presentation, I was trying to run my demo and it didn't work. I'm not sure why, but but I can actually use this terminal window. I can make font a little bit bigger, maybe. I'm sorry, the keyboard is really far away. But yeah, you can take a look at Nano. There it is, the code, and I can see this is the code that is used for flashing a light or a LED on my Raspberry Pi. All right, so back to my presentation. This is what we have right here. So this is the code that I was running. In this case, I've used Johnny 5. So Johnny 5 is just a library that is written in JavaScript that lets you actually interact in a very nice way. It has a nice little syntax that you can use. So basically, you define a board, as you can see right here. In this case, I have to specify that this is a Raspberry Pi board. And then when the board is ready, so it's an event-based language. So when the board is ready, trigger this callback and which will just define a LED and start blinking the LED. All right, so what should you use? If you want to build some IoT devices, should you use an Espruino or a Raspberry Pi? Well, it really depends. So, as the answer is for most things in computer science, it depends, right? Um, there are very specific use cases for each one of them. The Espruino is a tiny microcontroller. It will do one thing and it will do it really well. It'll be blazing fast and it'll just loop and loop and loop and just do that one single thing over and over and over. If you want to do some more complex things, then you might want to look into the Raspberry Pi. The Raspberry Pi can be useful for setting up a bunch of different things. It can control different devices, but you can do a lot more logic, and there's a lot more things that you can do. You can also use it as a server that you would have into your home because it's an actual computer. All right. So this is, pretty much all I'm going to cover today about IoT and JavaScript. Let's take a look at low-code interfaces. So there's been more and more conversations around the local movement in the last few years, and this is one of the subjects that I was really interested in recently. So what is low-code? A low-code development platform provides a development environment used to create application software through a graphical user interface instead of traditional hand-coded computer programming. The local platform may produce entirely operational applications or require additional coding for specific situations, enabling accelerated delivery of business applications. So what does this mean? Well, basically, it's just a UI that you can use to program an application. Now, why would you want to use that? You're a software developer, you know how to program. Why would you need an interface such as this one? Well, there's a few good reasons for that. First of all, well, it does make your life easier. But it is somewhat limited. Like if you really want to build a powerful application, well, there's still some value in knowing how to code and actually writing real applications. But sometimes you'll want to write an application where you want to give the power to your users, and that's a very good use case for low-code interfaces. So, say you're building an application and you want your project managers to be able to extract some information and build their own reports. Well, you don't want to build a full interface to give them the power to do that, and they don't know how to code. So, how do you solve this issue? Well, low-code interfaces are really, really cool for that. Another very good use case, and we'll see that in a minute, but is when you're building IoT interfaces and when you want to connect everything. But we'll get back to that. So low code, why should you care? Well, it does help to make things a lot faster. It helps you to build complex systems in a very visual way, and it lets you give that power to more users than it would traditionally with some actual code. So if you want to get started, I'm going to cover those two interfaces, those two low-code interfaces today. I'm going to talk about IFTTT and NodeRED, NodeRED, which is a really interesting project. So let's start with IFTTT. IFTTT helps all your apps and devices work better together. It makes it easy to build applets connecting various devices. You can find out more information at ifttt.com. But what does it look like? Well, this is actually what it looks like. So IFTTT means if this, then that. And basically you just build recipes, and recipes look like this. So in this case, if I have a new Twitter follower, then start my vacuum robot. This is actually one of my recipes that I have turned on. So, if you want to give it a try, if you want to help me start vacuuming my home, just feel free and go ahead and follow me on Twitter. So, and you'll start cleaning up my house. So this is the type of thing that you can actually do with IFTTT. Of course, there's a lot more and more useful recipes that you can build, but that is one example. There is a free tier which is available if you want to explore it. There's a paid platform which gives you a lot more powers, which is a lot more powerful. But the actual free platform enables you to do a lot with that. So it's a nice little interface that you can use, very friendly to use. But if you want to go a little bit deeper and have a little bit more power, might want to look at something like NodeRED. So NodeRED is a programming tool for wiring together hardware devices, APIs, and online services in new and interesting ways. It provides a browser-based editor that makes it easy to wire together flows using a wide range of nodes in the palette that can be deployed to its runtime in a single click. All right, so nodered.org, you'll find more information. Everything is built on Node.js, which is an interesting thing as well. If you want to get started, the easiest way that I found is using it as in a container. So Docker run, you can just start the Node-RED image, and immediately you have access to it. You can actually start exploring. There's a lot of different ways to actually use it. You can run it locally, so just download the code, install it, run it. You can use it on a Raspberry Pi. It's actually installed out of the box on my Raspberry, the latest version of Raspbian. Raspbian. So you can actually use it right there. Our Docker using the source code on BeagleBone, Android, or even on some of the major clouds. So you can use them directly right there. So really it's available pretty much everywhere. So just go ahead and give it a try. So this is what the interface looks like. So as you can see, it's just a bunch of nodes and you can just wire them together. So let's just create a new flow here and show you how this actually works. So this is the actual interface. As you can see, it's running on localhost 1880. So it's running inside a container on my local machine. And you can use some of those little events here. So I've got some of my common here. Let's use an inject. So inject is a node that will let me inject something. I mean, it's as the name implies. Let me make this a little bit bigger. There you go. So in here, I'm going to inject a timestamp. So we see our payload is the current timestamp. And we'll use a debug node. The debug will let me output the content of the message.payload, in this case, into the debug console right here. So I'm going to connect those two together. There you go. I'm going to deploy this application, successfully deployed. And now I can actually trigger this event. So I can just click on this button right here. And we've got message.payload, which is displayed right here. That's it. So I've built my first application. Of course, it's not a very interesting application so far, but it kind of gives you an idea of how this works. I was able to, put a button and then have something react to it. There's a lot more things that you can do, as you can see right here. I could use HTTP requests, so I could create an HTTP in. So whenever there's an HTTP request coming in, just display it on using the debug interface right here. In this case, that's not very useful because I'm not going to use that. But there's a lot of different inputs that you can use. You could use an interval. So let's do that. Every 1 second, right? We will trigger this and we'll just redeploy. And we can see it here, ping, ping, once every second. All right, so let's just stop this one. What else can you do? Well, there's this manage palette right here, which is a really, really cool feature where you can go and install different modules. And those modules are sometimes built by official or contributors or NodeRED contributors, or even sometimes just community-based. And you can search for a bunch of different things. I was curious. I was looking for a way to easily write to my Mongo database instance. So I was able to search for Mongo. As you can see right here, there's the NodeRED Node MongoDB, which was built by the NodeRED team. I can find out more information if I want to take a look, or I can just install it in my NodeRED instance. So I've got it installed right here. And if I go to my first flow, which is this one right here, this one is my Mongo out. So it will actually write some content to my Mongo database, to the flow data collection. It's an insert. Let's just insert the payload. And in this case, the payload is the timestamp. So very similar to what we had before. Let's also add a debug right here. So you can connect one event to multiple outputs. Let's deploy this. There you go. Let's clear our debug. And now what I'm going to do is that I'm going to actually trigger that. And in theory, if everything works, it should write into my Mongo database and trigger something into my, my debug window right here. So let's use that. Click. There you go. So we've got 162.336. I've got my admin interface for MongoDB right here, flow data. And if I refresh this, it should be the last one, 336. There you go. So it actually wrote into my database. All right. So uh, if you want to build an interface and you want to give people the power to write to an actual database, I mean, you kind of need to know how to code in order to do that. But using something like this, it gives a lot of power to your users. So now, my project manager can actually go in and edit some of the stuff, write some of the stuff into a database. If we want to decide what if we want to change what we're going to write here, let's change this to a JSON object. We can use the visual editor for JSON. So this is an object. Let's actually just use JSON because I'm having an issue trying to figure out this one. So we'll send a message and we'll say hello. And who do we send this message to? We're going to send it to Joel. Now my visual editor should make more sense. There it is. Um, oh, so this is the one I was looking for. So we've got, a visual editor for JSON. It's a little bit weird because I've zoomed in a little bit too much, but it kind of gives you the idea anyways. So this is what I'm going to send now instead. So let's just redeploy this application. Let's start or trigger this application again. We can see that the debug message changed and it outputted our new payload. And if I go back to my database again, let's take a look at this and refresh right here. And we've got this object that's saying, hello, Joel. All right. Go back to the presentation. So this gives you kind of an idea. There's a lot of different things that you can inject. I'm using sun event for different things in here. So based on, sunrise, sunset. So pretty much everything that you can think about, there is a way to add this to your NodeRED instance. Okay, so let's move on. The goal of this presentation is really to, talk about making smart homes, well, smarter. And there's a good reason for that. I was looking at all of my connected devices, and while most of them work, they do bring some value into my day-to-day life. But there's still a lot of problems with all of my connected things, my smart things. I mean, my thermostat temperature is kind of inconsistent. Not that it's inconsistent, but I mean. One of the big problems that I have with it is that it's actually in the middle of the hallway, in the middle of the house. And while it is great during the day, it kind of manages the average temperature of the house. At night, I wanted to monitor the temperature in my bedroom because that's where we are, and it's getting too hot. So we want to be able to lower the temperature based on the bedroom temperature. So how do I make sure that I can talk to my thermostat and tell it to use the temperature of my bedroom during night and the rest of the house during the day? Another thing that I have is with my smart light bulbs. So smart light bulbs. Let's use air quotes there because they're really not that smart. In this case, I bought some really cool light bulbs that I can connect, and I actually have to take my phone, unlock my phone, swipe up, find the application, and turn it on or off based on whatever I want to do. That's actually very annoying. I wish there was a way to be able to control that and add some automation to that. I also have an air exchanger, which is just a machine that filters out the air in the home, and it's kind of stupid. I have this one switch which is on and off, which is a manual switch. I wish it could do a little bit more there. And finally, my house plants are not connected to the internet, which is a big problem, of course, which big problem that we all have, right? So what I've decided to use here is NodeRED to actually make some of the things a little bit smarter. So this is some of my flows that I've got running on my NodeRED instance. The first one that I wanted to show you is the one for the lights, and that's one that is a little bit more obvious maybe. So what you can see here is that I'm actually missing one node. I'm not sure why, but basically what I did, and I should actually just add it. So whenever there's, let's change that to sunset. Sunset, there we go. So when the sun goes down, I wait at about an hour. So there's a little bit of time where it's not that dark yet. And after about an hour after sunset, it gets really dark. So 1 hour after that, so I delay for 1 hour. I use the trigger function. So the trigger function is really cool because it'll do something, then it will wait for 4 hours in this case, and then send another message. So it will send a 1 or a 0. And then I'll send an HTTP request to my smart plugs that are connected to my Christmas lights outside. Of course, the Christmas lights are not there in June, but that was used, which is why it doesn't really matter if it's broken. But this was used during wintertime. So 1 hour after the sunset, I'll wait. I'll turn on the Christmas lights, and 4 hours after that, I'll just turn them on. So I was able to add some automation. And basically, what I'm using for that is just an HTTP request. So I send an HTTP request, and it actually finds the light bulbs and turn them off, or the smart plugs in this case. So this is kind of the type of flows that you can do. Of course, I've got my plants, which I've decided to connect to the internet. So what I did is that I've actually used an Esprino device, very similar to this one. This one actually has a temperature sensor on it. I should show a demo of that one actually. But basically, it's the same thing, but it has a hygrometer, which tells me the amount of humidity in the soil. And wow, all of my flows are broken. I should check that out. But basically, it's actually sending a request every second. So the Esprino sends a request to my /plant route every second, giving the humidity level in the soil between, and that because it's an analog sensor, it will give me a value between 0 and 1024, which I then change into a value from 0 to 100. So I convert that into a percentage. Based on the percentage, I'll have a switch, which will trigger number one if it's under 25%. And the theory was under 10%, send another one. That should be a number. There you go. So now I have 1 and 2. And on number 1, what I do when it's under 25% is that I actually find an email, and I'll send an email to myself when it's under 25%. So I can actually, receive an email saying that, hey, I need some water, which is very convenient. The other thing that I wanted to do, because I look at Twitter so often, I can use Twitter. Let's install this one. Let's install it. And basically what I do is that I have the, once it'll come back, there it is. So I can use Twitter out. And when it's under 10%, I'll actually tweet about it so that it really notifies me that there's a watering problem right here. So this is a kind of a fun flow that you can use. Of course, I've also used my MongoDB here instance just to keep track of it. And whenever it's under 25%, it will actually write something into my database so I can kind of monitor the things that are going on. What else did I do? I've checked for my air exchanger. So it has a sensor right here. It uses an HTTP request as well. Gives me two different requests. One that will one is an interval. So every hour it will check. It'll check if it's during daytime or nighttime. So it's kind of noisy. So during daytime, I wanted to recirculate the air every 20 minutes. So it'll turn on and then off after 20 minutes. Or if my air sensor, gas sensor detects that the air is bad, or if I burn something, it will actually trigger it for another 20 minutes automatically, and then it will turn it off. So we've got the HTTP request here. And finally, my thermostat uses kind of the same type of thing. I've got the temperature sensor, just like this one right here. And it checks during if it's daytime or nighttime, and then it will make a decision based on that, and it will either turn it on or off based on the current temperature. Let's actually take a look at this tiny device. I've still got a few minutes left. So I've got my VS Code editor right here. I know I've got my temperature code right there. So this is the actual code. The one that I use inside my home is a little bit more complex. So it has a LED just to kind of give me status updates. But this one has only the temperature sensor. So let's just flash this into our device. So this is my device. It is now being flashed, and so it's not blinking anymore. So that's a good sign. That's because it's running the new software. And there it is. You can see the blue LED flashing. That's because it's connecting to the Wi-Fi. It is now connected, so all good, all good. And what will happen now is that every minute it will actually take the room temperature and send that to this URL right here. You might recognize this being the IFTTT.com. So IFTTT, one of the recipes that you can use is webhooks. So I can actually create this webhook. So whenever there's something that comes into this webhook, What will it do? Let's take a look. This is where it is, my applets. All right, so if the webhook is triggered, then add a row to the Google spreadsheet, which is right here, which has the date and the temperature, humidity. Let's just wait for it to actually trigger this. Whoops, I've lost it. There it is. Should be every minute. So I don't know. It hasn't been a minute yet. So I'll continue. Oh, there it is. So request is sent. Congratulations, we fired the event. So that was the response. And there it is. It was just added. You might have seen it into my Google spreadsheet. You can see that it's 27 with 45% humidity right now. It is a hot day and it's only 7:30. So it's going to be really hot today. So you can see how everything was connected together and using almost no code in this case. I was able to trigger some events, and I can do some really cool things with that. All right, so IoT and JavaScript, should you use them together? They're amazing together. It makes it so much easier. I'm a JavaScript developer at core. I like to be able to use JavaScript everywhere where I can. And this is actually what I've done right here. Low-code interface, really nice if you want to be able to give power. But even without, even for a programmer, writing the code for all of this, there it is. Come on, merge. Actually, yeah, writing all of this code for delights or even it's relatively simple, but it's still a lot of code to write. If you want to detect when did the sunrise occur, well, that's it's some work. You have to actually code all of that. Using those event-based interfaces and just those flows make it so much easier to write those applications. And IoT and low code, they just work well together. They're both really event based. So when something happens, do something. So it really makes it easier to use low code interfaces with IoT infrastructures or ecosystems. So this is what I had. Thank you very much for attending. Thank you for being here. I hope you have a great rest of the day. Not that there's a lot of sessions left. My day is still starting. So thank you very much for being there. If you want more information, easy URL 2/JS no code is the URL where you'll want to go. All of my code samples are all there and more slides are there and so on. So feel free to take a look. And thank you very much for attending. I'll stick around for another 2 minutes. If you have any questions, feel free to ask them in the chat. I'll be monitoring that for the next 5 minutes. Thank you for being here. All right, doesn't seem like we have any questions, so that's all good. I am in the Slack channel if you have anything, or you can find me on Twitter at Joel__Lord. Thanks for watching.